Today we're doing solve by elimination, and it's just the second way that we learn to solve algebraically. So we learned substitution yesterday. We've learned to do it by graphing. Now we're going to learn to do it by a process called elimination. So if you look at this, all three of these equations, or all six of these equations, are true. And look at, where did the third one come from? Well, didn't we just add the first two together? 3 plus 7 is 10, 5 plus 2 is 7, etc. Now right here, that became 0. So the first two came from, the third came from adding 1 and 2 together. So we can see that if we add two true equations together, we end up with a true equation. So let's see if we could do that algebraically. Let's add these. 2x minus 2x, that's just 0, it cancels. 4y minus 3y is just 1y. 10 minus 8 is 2. Okay, look what happened. X was eliminated. I was able to solve for y. Now, how could I solve for x? That was easy. Those went away, and I was able to solve for y quickly. So how do I find, for y. So now how do I find x? Well, the same way I did on substitution. This process starts differently than substitution, but ends the same. So we take either equation, I'm just going to use the first one, and instead of y, we substitute the 2 that we solved for. So 2x plus 8 is 10. Take away the 8. 2x is 2. Divide, and x is 1. So what is the solution? 1, 2. So it started easily. So I guess I want to look then for equations that are set up like that, where either the x's are opposites or the y's are opposites, because then it would be easy to just add the equations together and eliminate something. So this is called linear combination or elimination. I usually use the word elimination, where when you add them, you make one variable disappear, and then you can solve for the other one. So if we look at this, Mr. Bro bought 3 staplers and a package of 3 staplers, a package of 7 binders. Miss Orsi bought a package of 3 staplers and a package of 4 binders. Mr. Bro spent 45, Miss Orsi spent 36. And so here's an equation that represents it. If we added these two equations, we didn't make anything eliminate, did we? Because there were no opposites. But what if you multiply the whole, pick one, second equation by -1? The first equation stays the same. The second equation, everything changes sign. So in this case, they all become negative because they were all positive. So now if I add them, is the variable eliminated? Yes. I get 3w equals 9. Then I divide by 3. W equals 3. And I apologize for using L and W. I changed this situation, and did not change the letters. We could multiply both sides by any number. The reason we multiplied one of them by -1 was to make these opposite. And that was the easy way to make opposites. I could have made it other ways, but it would have been a lot more work and harder. Okay, let's substitute. So I say we always go back to one of the original equations. I'll just pick this second one. to substitute. And what did we say? Okay, so we said W is 3. So 3L plus 12. 3L equals 24. L equals 8. So it was $8 per stapler and $3 per binder, because it's a word situation. All right, let's solve this second one. Now, if I added them right now as they are, nothing would eliminate. But do you see an easy way to make opposites? If I could make one of these two x's negative, wouldn't that easily make opposites and make it eliminate? So I'm going to choose the second equation. It doesn't matter which. Let's write the first one down and then multiply the whole second equation by -1. What that does is that changes the signs of everything. Don't forget to do every single part of the equation by the -1. Now, when we add, the x's eliminate, and look how easy it is to solve for y. Now, all I have to do here is go back to one of the originals. I'm going to pick this one, 2x, and then plus y. Instead of plus y, I'm going to put -3 because y is a -3 equals -5. Now, I'm going to add the 3, divide by 2. X is -1. So what is the solution? -1, -3. So that process is called elimination.